For our next speaker, please give a warm applause to Sebastian. He is VP of AI at SAP, the backbone of almost any enterprise out there, where he also leads their AI core model. Without further ado, because we're running a little bit up behind, Sebastian.
Thank you. Thank you. It's a pleasure for me being here, and I'm representing SAP. And just before I go into the slides, let me just explain a bit about SAP. As you could say, it's a hidden champion. We talk about that in Germany. It's the most valuable German company, more valuable than all the car manufacturers you may know. We're developing software, and in the software market, we're basically digitizing all the processes for companies, from manufacturing over back-end tasks like cash flow, like recruitment, like logistics, up to customer engagement tasks, interacting with our customers. And I think it's clear for everybody that AI for a couple of years now has been changing and disrupting the way people are doing business in these areas, and SAP has been applying AI for many years to these processes, but of course Gen AI is disrupting these processes and these tasks again. Now, sorry. It's clear that with generative AI, we're moving into a new era, but it's also important to see that we're not moving away from the AI applications that are out there and that are already there. So from the, let's say, 1970s till 2010s, it was all about analytics, statistical models. Then we had machine learning and most dominantly deep learning, so a machine learning with high data volumes as part of the mix. And we have seen that these statistical methods they continue to have more and more adoption. We saw over the last years that also machine learning, deep learning applications got more and more adoption, and the Gen AI part is not replacing that. Is basically putting out on top additional features, additional functions, additional capabilities for us to even to improve these processes even more, to digitize even more, to automate even more. So what is this disruption about generative AI? We heard about large language models quite a bit. I think for me it's important to give you a bit the view from an industrial point of view. So there are lots of application areas, of course, but when you look at it from industrial point of view, you're moving from classifying applications or capabilities to generative, so generating data, generating text, generating videos, generating images. You're moving from supervised learning, where people are telling the model, telling the algorithms what they have in front of them, so you need to label the data, to self-supervised learning, where the machines themselves are creating their training data sets or labeling their training data sets, you could say. You go from predefined capabilities like translation, like sentiment analysis, to emerging capabilities. That means a model can have multiple capabilities that you cannot predict beforehand or that you haven't foreseen. And in short, we're going from narrow single-purpose AI systems to AI systems that are broad and general purpose. And there are many cool things about it. First of all, because it's mostly language-based, now we're at the point where non-technical users actually have access to it, and they don't need intermediaries like data scientists to help them set up systems. They can interact directly and define the tasks in natural language that they want to have solved. And what you also see is that if you want to apply these Gen AI models to a task, they can be used by prescribing these tasks and describing these tasks without the need to retraining them on that specific task over and over again. Of course, you can do that and it yields better results, but it's clear that we can now start to invent our own task and start to use general AI models as is. And you can do that on a couple of data. You can do that, of course, with certain adaptations that are then more technical, like prompt engineering, embeddings, fine-tunings. But at the heart of it is non-technical users are able to fulfill multiple tasks at the same time without being prescribed in all these areas. And what I wanted to show you is one of the application areas that we see on the industry side. And I will just play the video here of a person who in an SAP system is creating a job description. And basically there is some information that we have in the backend, and you click a button and the AI system is providing you with a text about a certain job description. Now, it's not important that you read through that, and probably it's also not very exciting to see that a large language model is able to create text on your behalf. But what basically is happening here, what is different to how you're interacting with ChatGPT, is that not a human provided the information or provided the request to generate the output, but a system in the background was doing that. So it is system to large language model to user. It's not user to large language model to user here in this case, right? And what you see is that what is happening in the back is that the system is providing additional information for the task to the large language model without the user knowing about it. Like, for example, what's the location in which the job posting should be, what's the language, what's the seniority of the person, what's the team doing, all this kind of context information that we can add into what we call technically a prompt, so the request to the large language model. We can all bake that in. We can provide information about how a good job description looks like, what's the format of it, what should be the tone of it. All of that you can basically generate automatically, and then you give it back to the human. And of course, what we don't want is automatic posting, but we have the human then being able to review it, to adjust it, to adopt it, and to take the decision finally to post that. From a process point of view, it's of course interesting. From a technical point of view, I would say for me, it's kind of, as I said, it's kind of clear that you can use a large language model for text generation. So let's look into another application that shows the power of large language models, maybe from an area you haven't seen so far. And if I'm playing this now, you see here a request, give me the overall interview assessment of a candidate called Brady Johnston. And what you see now, you don't have to read through it, but basically is a monologue of a large language model trying to figure out what to do in order to find the right response. And you will see that the large language model is creating a plan. How would I interact with a HR system? What kind of request would I have to make? What is the API call that I have to make in order to fulfill this? If I do the API call and I get a certain system response, what would be the next step? What would I have to do now? And in the end, it comes up with, I can just read it out here, for candidate Brady Johnson and ID so-and-so, job application ID so-and-so. The overall interview assessment has a positive rating and an average rating of 3.5 with no comments provided. What does it mean? So we're using a large language model in a way that people that are interacting, for example, with ChatGPT don't think about it being possible or it being relevant. But basically, we have a user giving input, and again, it's not the LLM providing the output to the user, but the LLM creating output to a system, interacting with a system in order to retrieve the right information from the system to give it back to the user. And this is changing the way we will be interacting with systems, we will be interacting with machines in the future as well. So in a way, when you look at graphical user interfaces, you click, and I showed you how you click on an HR system in order to fulfill a task, and then you say, click the button, generate this, or show me this. Now imagine you would have to do that in order to figure out what's the overall assessment for Brady Johnston. I can tell you on an HR system, you have to figure out where's the candidate, then you have to select which application for this candidate you're interested in. Then you go to the application. Then in this application, you go to the tab telling you about what's the feedback from the different reviewers, and then you aggregate the information yourself. That's what you have to do. So as a human, you're defining the task, but at the same time, you're also interacting with the backend, right? So you're pressing the button, you're getting feedback from the system, you analyze the feedback, you press a button again, or you put in more feedback, you interact with the backend. What we can do with large language models already now is we can automate that part. So a human still provides the task, but if you instrument a large language model in the right way, like in an agent pattern, the agent can interact with the backend system and automatically provide this, the interaction with the backend system, providing you only the output. And that means, from a higher level perspective, that we're changing the way humans are interacting with machines, how humans are interacting with systems, and we're going from humans executing tasks to humans supervising tasks. So basically, everybody now can, with these changes, become kind of a manager of things, right? So instead of me saying, I write a mail now, or I want to know, or I go in the HR system and click through, I'm just saying, go off, tell me what it is. Something's coming back to me, maybe in a minute, maybe in an hour, I don't care. And I can give tasks out to agents and look at the results only. So I'm supervising. Humans will be supervising what machines are doing. We're not going to have to explain to machines every single step they have to do. And SAP is, of course, looking into these new capabilities. We're putting a lot of AI capabilities in all our processes, be it in the financial processes, in the HR space, in the logistics space, in all these spaces where we have software. We're putting out new capabilities. And of course, we're doing that in a trustworthy and responsible way. So AI ethics has been a very important discussion point and topic for us for many years. We have created guiding principles for AI ethics. You can see them here on the left. I would say right now they're kind of market standards, so all the big companies do have these guiding principles. We heard from IBM, but you can see that all the big software companies have that UNESCO has put out these guiding principles, OECD, and we see that this is converging to a common standard. So I believe that sooner or later we will only have one set of guiding principles that everybody is obeying to. Maybe it's the UNESCO one, I guess. What we did on top is we created an AI ethics steering committee. So we have from all board areas, we have senior executives coming together to discuss the topics and to look especially into high-risk cases. So we have a process that, and here it's called policy framework, that basically prescribes certain requirements for all the AI-related functions and features that we're putting out. This policy is binding for every single employee at SAP, also for our partners, and is basically signed by the board and by all the workers' councils worldwide. That's how we're committing to it. And we have the AI Ethics Steering Committee that is basically overseeing that process and reviewing the policy adherence, especially for the high-risk use cases. So everything that is marked and assessed as high risk, and that could be, for example, review processes in HR area, this is a typical high-risk area, but we're in general obeying to the AI Act definition of it. We're reviewing by the AI Ethics Steering Committee. We also have an external advisory panel, and I think we have been among the first companies worldwide and the first European company who had implemented this advisory panel. And we have a trustworthy AI work stream. That's the execution element for us. I'm leading that basically globally for the company that is running these policy reviews, that is setting up the basic tasks for developers, for consultants, for marketing people, and so on and so forth. Now, for generative AI, there are, of course, a couple of things that are special in comparison to, let's say, AI ethics that we have been talking about for the last, 6 to 10 years, I'd say. So, when we talk about transparency and explainability, of course, some of the ideas that we had about how do we make sure that our systems are transparent and explainable are not holding anymore. And I would say we have to think about how we can still use these systems for the right purpose, and let's say keep or basically say keep our guardrails without ignoring that certain boundary conditions do not hold. For example, that information about training data and architecture in many cases is proprietary right now, or that providing clear and simple explanations for why a model gave certain output is not achievable for foundation models like large language models. Or when we talk about bias and discrimination, you see that basically an idea of how to address bias and discrimination. Most people say, okay, you need a balanced data set. Now you look at large language models. I would argue there are no balanced data sets that are used for training these large language models anymore, and you can see that, for example, most of the LLM providers, all of them, I believe, but most of them are stating that they're using common crawl of the internet, right? And you cannot argue that the internet is a balanced data set when, for example, in Europe, more than 95% of the population has access and can create information on the internet, and in Africa it's less than 50%, right? So if you would look at what's the representation of different societies in contrast to their magnitude, you cannot say that these mostly uncurated data sets are balanced in that regards. Another problem is that many of these, or the generative AI algorithm, most of them, they're creating unstructured data where it's much harder to detect bias. It's much harder to figure out in what ways they have potential of discrimination. And of course, when we look at human agency and oversights, don't want to repeat myself, but if you think about what does it need for a human to provide oversight to about what an algorithm is doing, then often if you get a recommendation for publish this job posting or hire this person or whatever the recommendation will be, you want to have an explanation for it. Now you can use large language models, for example, to provide explanations, and they're in most cases they are sound and they're probably easily understandable, but they're not a real explanation for why the large language model came up with the recommendation in the first place. And we heard that in the first talk, how the math is working to come up with it. So even though you get good explanations for why things happen from large language models, they're certainly not the explanation for why the large language model came up with a certain suggestion in the first place. And we have to decide then, as humans, is it good enough for us to get a sound explanation that is reasonable, or do we want to know why the foundation model or the large language model came up with this suggestion? I think these are, in my opinion, these are very relevant discussions, and it shows that when we're using generative AI, we have to make sure that we adhere also in these areas where it's not so easy to our guiding principles on AI, and that's what SAP is doing. So we're looking into these Gen AI cases as high-risk cases, and we're reviewing them one by one, because what we want to do is we want to provide these AI capabilities within our products to make it as easy as possible to use them, as accessible as possible. We want them to be relevant to, let's say, to increase efficiency, to increase the way humans, or to better the way humans are interacting with systems. But of course, we also want to provide these capabilities in a responsible way and build on ethics and data privacy standards. Now, when we look at the human software industry, I want to make one or two more comments about that, now stepping out of what SAP is doing. When we look at the European software industry, we see that with large language models, we obviously gain efficiency in most of the industry sectors, not only in the back office processes, but also in the manufacturing and also in the customer interactions. That's clear. At the same time, we see that because we have the model providers, there's a big risk of creating new networks and platforms that are winner-takes-it-all, similar to or monopolies or oligopolies that are created, that are, let's say, creating or that are a magnet for data and are improving faster than their competition, so that at the end you can see that now with OpenAI, you have single companies that are running these capabilities and are providing these capabilities. There are a lot of competitors as well, but and we're working with a lot of LLM providers internally. We're using, I think, more than 10 models at the moment. My team is providing to SAP development teams internally, but predominantly is one provider that gets used. And so I see a clear risk that we have this winner-takes-it-all situation coming up. What is also clear is that when you look at it from, that's the provider side, right? But also if you look at the consumer side, if you look at the European industry as a consumer, a lot of the successful adoption depends on your own digital maturity. So how much did you digitize your processes until now so that you can do the next step? And of course, it also depends on how good is the access to these new capabilities, how easy is it for you to integrate that. And when we think about who are the current providers of large language model and other foundation model technologies, of course, we as Europeans have to think about, is our digital autonomy at risk, similar to what we see when we look at hyperscaler environments at the moment. And I think it's very important for us as Europeans to think about, do we want to go further in the pace that we're going, and do we feel that the way we're working on generative AI at the moment is leading to digital autonomy or not? So when what we're predominantly talking about in Europe is regulation, and I think it's important. It's important, I showed you also from an SAP perspective, to behave in an ethical way, but it's also important that we're not creating adoption barriers, because they may become hindrance for us and create competitive disadvantages for us, not just for the software providers, but for all industries who are then not able to create these efficiency gains on our side. And we know that in Europe we're a high salary sector, so we need to distinguish to other areas in this world by efficiency, if we're not able to reap these efficiency gains effectively on large language models, we will be in trouble going forward. So therefore, in my opinion, it's good to see that the European Union and that the national parliaments are discussing about a unified European vision. But I would also like to state a couple of things that, in my opinion, are worrying at the moment. So let's start on the right-hand side. We said that there's a lot of productivity gains if you're using large language models, and here you see my way of defining large language model at the bottom of it. And what is happening is that companies, they use curated data sets, so they have full control of the data that is going into a large language model, and they know what to do with the data when it comes out. So for example, I showed you this HR use case where you're generating a job description. You have full control, or the system has full control of the data that is put in there, like, okay, I'm submitting the job, the location, I'm submitting the salary maybe, or whatever information. A company is staying in control of it. Then a description is coming back, and the company thinks about what to do with it. Do I post it now? Do I change it now? So the adoption part of it is very clear, and when it comes to, for example, data privacy, it's also very clear that the company has full control of, do I submit person-related data to this model or not? And if I do that, what do I do with the results? So I would say on the provider side, using large language models in a compliant way, we as Europeans have little issue with. And that's also traditionally. So for example, also for face recognition algorithms, we can handle that. We can do that in a compliant way. For example, GDPR compliant. Everybody has that in their phone. Everybody has that in their on their laptop. Lots of access control is working that way compliantly also in Europe. But if we go to the provider side, what is happening is that we have a lot of large data sets, and I mentioned one, which is Common Crawl, that is, you could say from a data privacy perspective, contaminated with person-related information and with other information. Now, what everybody in the field does, the European companies, the American companies, the Asian companies, they're taking all these data sources and they're not looking into them one by one. So they're not figuring out what's the information that I can dig out for Sebastian on the internet. But what they do is, in an unsupervised training, so without looking into the data, the algorithm is determining how to train on it and how to derive meaning out of it. They're creating a model. And this model then can be applied on the right-hand side in a GDPR-compliant, AI Act-compliant way. But the generation of it is, I would say, bound to different regulations at the moment. So if you're training such a model in the US, if you're training that in Asia, you can do that without GDPR regulations in a very easy way. If you're doing that in Europe, you're risking that someone is coming saying, did you process my person-related data? Please take it out of the data set. Where has it been used? And so on and so forth, until, regulation is, there's no court ruling for that right now, but there's a huge risk for European companies like Aleph Alpha, like Mistral, or others working in this field, Nionic, for example, to do it that way. And the reason is that our regulation at the moment is putting a lot of burden on working with person-related data, even though they're just a byproduct to these big data sets that you need in an unsupervised fashion to train these models. And if we're not changing that, if we're not creating sandboxes, if we're not creating, let's say, support for companies to train these models in a competitive way in Europe, we will be dependent on American and Asian providers, as we're today already dependent on American and Asian providers on face recognition. There's no face recognition provider in Europe because of this problem. At the same time, everybody is saying, okay, this is the most delicate way to do face recognition, but you can use it GDPR compliant. You have it on your phone. It's possible to use it, but it's very hard to produce it in Europe. And if we don't want to have the same situation for large language models, we have to be very critical of the regulation that is coming to make sure that Europe is also, European companies are also potential producers. And wrapping up, I would say, in my opinion, the European Union and Europe is, of course, very suited to determine and put democratic values into AI and to define how ethical AI is working. I think it's clear that we have great education and human capital for doing so. We have great universities, but I also see that when we look at AI research at the moment, it takes, what I was reading, about $50,000 in terms of credits for hyperscalers in order to produce the right results to publish at an A-star conference of AI and machine learning. Most universities in Europe are not able to create these funds in order to play a top role in these research areas anymore. So we have to think about how can we support these great talents in order to do research. I think it's also clear that when it comes to compute infrastructure, when it comes to data infrastructure, we need to invest in Europe. At the moment, there are very few places where it's possible to train large language models compared to US and Asia. And there's that limits also the creation of companies that are doing so and are becoming providers. I think it's very important that we as Europeans are working and collaborating. I think Europe is very unique with the number of languages, the number of different systems, the number of different cultures. And I think we have to unite ourselves to also make this a part of the Gen AI roadmap that we're following. And of course, and that's my last point here, we need to balance the regulation that we're creating with capabilities to make innovation possible. So if we are true to ourselves and we say, okay, certain regulations are necessary in order to safeguard ethical AI, then we also have to provide means for European companies to balance these guardrails in order to have European innovation in that field as well, and not to become completely dependent on monopolies that are forming elsewhere. And with that, thanks a lot.
Thank you, Sebastian.